Live stream. Hi, everybody. We're just waiting for a few minutes to get ourselves set up on the LinkedIn and YouTube. So take your time, go back, get some coffee, get yourself all ready, and then we'll be ready to start the show. And by the way, if you're wondering, this particular session happens to be about ingesting data from Delta Lake into SageMaker Studio. So yeah, you're on the right channel. So just give us a few minutes to get all set up, okay? And meanwhile, while we're waiting for everybody to chime in and to get in LinkedIn and YouTube almost ready, why don't you go ahead and tell us where you're based out of? For example, I am based out of, you're not going to believe me, sunny Seattle. So that's where I'm based out of. How are you, Vedant?
I'm based out of a sunny place as well. I'm based out of Houston, Texas.
And I am based out of sunny St. Petersburg, Florida.
That's right. So, man, we're all sunny today. This is pretty sweet. All right. Well, okay. I think we're good to go. We have the LinkedIn live stream that's up and running. We have the YouTube live stream up and running, and now we have Zoom, which a bunch of you guys are here as well. So let's start the show. We're going to start off and kick it off with Carly. Carly, you've got a bunch of announcements to make, so let's go ahead and do it. And by the way, if you're not familiar, Carly is our go-to person when it comes to all things Delta Lake, social and marketing wise, events wise. So happy to have her actually join the conversation more often, as opposed to just hiding behind the scenes. So take it away, Carly.
It's so easy hiding behind the scenes, though, Denny. I believe, do you have a few of those slides that you could present, Denny?
Oh, sure. Actually, I did not happen to have them handy. My apologies. I thought that this is me still going ahead and trying to get myself organized, but not a big deal at all. I will give me 1 minute and I will have it all taken care of.
Perfect. Well, in the meantime, we have some really exciting events in store in the next 2 weeks and in June. So 1 week from today, May 24th, Wednesday, May 24th at 9 a.m. Pacific, we will be going live on the Databricks LinkedIn and YouTube. Matej Zaharia, co-founder and chief technologist at Databricks, our lovely Denny Lee, and Martin Brunn, senior software engineer at Databricks, are coming together for an online meetup. Use Spark from anywhere. This is going to be a very exciting conversation. I will drop in the RSVP link in this chat after this. We also have Thursday, May 25th at 9 a.m. Pacific, a wonderful D3L2 session with Andy Grove, who has been specializing in query engines and distributed systems. I will also include that RSVP link. And lastly, June 26th to the 29th, we are coming together for Data and AI Summit. Top experts, researchers, and open source contributors across the data and AI community are coming together June 26th to the 29th. If you use the code ETLinux400, you can save $400 off the regular price of a full conference pass. That code expires June 2nd. And now I'm going to flip it over to Denny for today's discussion with Vedant Jain, and they're going to show you how to train ML models and how you can take advantage of the capabilities offered by Delta Lake using Amazon SageMaker Studio. Thank you.
Perfect. Carly, thank you very much. Really appreciate you diving in like that. Without further ado, Vedant's going to start presenting the slides. Because he's going to be the guy to run things. Meanwhile, I wanted to call out that, hey, Vedant and I are old friends. We used to work together at Databricks. And so when we found an opportunity for him and I to go ahead and speak together, it seemed to make all the sense in the world. A lot of the stuff that he's been working on is very much related within the realm of the SageMaker world, which is awesome and sweet. And myself, I'm very, well, you probably know me already, a little on the biased on the Delta Lake side. So that's why we figured we have this session together and talk about SageMaker Studio for machine learning on Delta Lake. So Vedant, you want to take it away, or would you like me to go ahead and continue on? We didn't prep very well.
Oh, that's fine. I mean, I can just introduce myself real quick, and then I can, and then you can start talking about Delta Lake and do a brief overview of the agenda.
Perfect, Vedant. Why don't you introduce yourself, please?
Okay, great. Hello, everyone. My name is Vedant Jain, and I'm currently working at Amazon Web Services. I am a senior AI ML specialist, and I work directly with all of the AI ML products within AWS, and I work on strategic partnerships. So there are multiple very specific companies that I work with, in my prior lifetime, I used to be at Databricks. I was a solutions architect at Databricks, and that's how I got to know about Delta Lake and got to work on some very interesting projects regarding Delta Lake. So, when we got this opportunity, it was a great time to bring SageMaker Studio and Delta Lake together because of all the great innovation that's going on in the open source community. So that's exactly what we're going to talk about today. So back to you, Denny.
Awesome. Thanks very much. All right, next slide, please. So, there we go. So our agenda today basically is we're going to talk about the Delta Lake fundamentals. We're going to start with that. And so just in case y'all are not as familiar with Delta Lake, I'm sure most of you are, so we're going to breeze through it quickly. But at least if you are not as familiar, the slides will be available and for you to go ahead and actually access them and refer to. Then we're going to talk about the benefits of machine learning on Delta Lake, because that's always a good thing. And from there, we'll switch over to Vedant to talk about an introduction to SageMaker Studio, SageMaker Build ML Models, a demo, and call to action. Now, if you have any questions, if you're on our Zoom, more than welcome to go ahead and chime in on the Q&A panel to ask your questions. Now, please keep your questions related to SageMaker Studio and Delta Lake, please, okay? We do want them to be around these two concepts, okay? And if you're on LinkedIn, again, you're more than welcome to chat on the comments section, and also YouTube. Same idea. Go ahead and chat there. So I'll be monitoring all three. I'm going to be a little slow in the beginning just because I'm going to be talking first. But yeah, let's go ahead and switch to the next slide and talk about the Delta Lake fundamentals. And so for those of you that may or may not be familiar with Delta Lake, Delta Lake is an open storage format that brings ACID transactions to big data workloads on cloud object stores. This is the key ingredient to this concept of building lake houses. Lake houses are this culmination of the data warehousing world, from terms of business data, and the data lake world, bringing these two concepts together. Next slide, please. Okay, so we're going to do Delta Lake Foundation or Lake House. Yeah, just go ahead and skip to the next slide here. All right, so the context that we wanted to talk about is that when we talk about lake houses in the first place, it's to say that you have the manageability and the simplicity and the transactional reliability of a data warehouse, plus the scalability and the flexibility of a data lake. Take the two concepts, the best of both worlds together, and then that's what you have with a lake house. A lake house is basically taking advantage of your cloud object storage. It has the scalability and flexibility of it, yet at the same time having the transactional protections around that data. I could go on for hours about the pain of a data lake, about schema on reads. I won't, because then you're all going to get bored real fast, but that's the context. The idea is that you take the best of these two worlds, so that way you have the flexibility to make sense, process, read, do AI, run machine learning algorithms, AI against all of your data. Next slide, please. And so the key features of Delta Lake are ACID transactions, again, to protect your data, the context of scalable metadata, the ability to go, often more times than not, the metadata of your data lake ends up becoming more slowing processing or slowing querying down than the actual data itself, just because it actually has to identify what files it's supposed to read or which files it can skip. So the metadata process actually becomes extremely painful. And so Delta Lake has the capability to handle petabyte scale of tables with billions of partitions and files, and because we have very scalable metadata. Time travel, the ability to revert to old files, old versions of the data, so you can audit, roll back, anything else. It's definitely open source. This is coming from Databricks, so we've got a lot of the open source pedigree around Apache Spark, MLflow, and of course Delta Lake. So open standards, community driven. Always a fan of that. Unifying the concepts of batching and streaming. This is super important because as you look at more and more data processing, streaming is not just for real-time applications, though that's super important, by the way. I'm not trying to disregard that. The idea is that you should be able to apply your business logic, i.e. what logic you apply to your data, irrelevant of what that latency is, whether it's supposed to be super fast or you have a latency of 4 hours or 1 day. And so the business logic shouldn't change. Delta Lake has the ability to handle extremely fast queries and processing of both your streaming and your batch data. So that way you can go ahead and separate the business logic from the latency of your processing. And with advancements in structured streaming, or for them, or the Flink connector, or you want to go ahead and go old school, well, maybe new school, Rust, and actually use Rust APIs to go ahead and write directly to Delta, we're good. Yeah, absolutely. So this is the context. Schema evolution enforcement. Why? Because the schemas might change, so you're going to allow them to evolve. Yet at the same time, you want to enforce them so that way people aren't just going randomly writing files directly to your data lake to destroy them, right? You don't want to do that. Audit history, DML operations, all very important key features. Next slide, please. So if I leave you nothing in terms of the key differentiators of this community, it's about performance, community, and reliability. In terms of the performance, some of the concepts I'd like talking about. Now, of course, this number, 1.7 exabytes, this is from Databricks because that's the only place we can actually get the numbers from, okay? But in the context of Databricks, there's 1.7 plus exabytes processed a day, not stored, processed. So this is in storage is actually much higher, but we like using the process numbers because this is showcasing just the fact that we're talking a ton of data. This is based off of 7,000 plus companies in production. So that's actually how Databricks is able to go ahead and provide a reliable service because it runs on Delta Lake. And then over the last 3 years, this is last year's number, so I'm actually not sure what this year's numbers looks like. But last year's number, there's an increase in contributor strength over the last 3 years of 663%. That is, there are more and more open source contributors contributing to the Delta Lake project, which is really, really cool. I'm super happy about that. Now, next slide, please. And so this is also from last year's number. I'm not sure why I accidentally blocked out the Data and AI Summit 2022 logo. So that's my bad. That's on me. But this is from last year's. And so basically there's, if we go to November of last year, basically is 11.1 million downloads a month. The numbers are great, but the key thing is I wanted to call out here is that every month there are multiple releases, whether it's Delta Spark, whether it's the Delta Rust Python APIs, whether it's Flink, Delta sharing, whatever else. The community's super active, and so we'd love you to join us if you actually have some cool ideas. For example, there is already in the alpha stages a Go Delta Lake API as well. There are APIs for Delta Dask and Delta Ray. So again, pretty cool stuff. So come join us. All right, next slide, please. Now, gave you the context of why Delta Lake. That's great. But for those who are into machine learning, which is the bulk of the folks I'm sure here who are here today, like you're wondering, why? Why do you care about Delta Lake and why are the benefits of machine learning? So next slide, please. And so the key thing I'd sort of like to remind folks is that the data science lifecycle isn't just about the part where you're serving models. It isn't just the part about you're even going ahead and training the models. Obviously, they're super important, so don't get me wrong, but there's a lot of other work that has to be done. You have to take that raw data. You have to be able to scale that up somehow and prep it and process it. So there's all sorts of different tools that are out there. I'm leaning more towards Spark or Rust, but there's other systems like Flink, like Trino, like Presto. This is all good. Like we're not trying to tell you which one to use. You have your reasons for doing this. The point we're trying to get at is that, but it involves taking a lot of raw data and prepping it and processing it and making sense of it and filtering it and so forth, right? And then when you do the training, you're going to go ahead and use things like, PyTorch or R or TensorFlow or Spark or XGBoost or whatever it is that you like using out there, okay? Because your data scientists have their particular tools of choice, okay? They're going to tune it, and you need to be able to scale that process as well. And so I'm more than sure Vedant's going to go and cover about how SageMaker helps with a lot of that stuff, which is exactly the point. That's why we have today's session. But that's an important aspect. You have to have these systems that can scale for your data prep, for your raw data, scale for your tuning, scale for your training. And then you have to deploy all those models, okay? There's a model, we're gonna push those models out. It could be Docker, it could be SageMaker, it could be MLflow, I don't care again, right? You're gonna choose your tool of choice. Again, Vedant's gonna talk about SageMaker because that's today's session, but the point is that you have to be able to scale that too, right? And so all of these things fundamentally require some form of data reliability, the ability to ensure that whatever you're doing with that raw data, whenever you're prepping it, when you're training it, and then you're deploying it such that the model, such that they're going to go back and re-look at the data again, because you're going to incrementally update the models based on new data. Guess what? You have to know what data you're working with. You have to ensure the reliability of the schema. You have to ensure that there's scale relating to all of the stuff. Right. So putting all this together, and of course, hey, wanted to just give a call out to Kunmi. Hey, don't forget Mojo. Yes, there's a ton of Mojo around all of these things. Well, guess what? Delta Lake allows you to have all of that. Next slide, please. And so that's the context. The role of data engineering is super important. It allows and enables your data science and your analytics. It allows you to develop, test, maintain your pipelines, and it allows you to productionize those data science models. There's that yin and yang of basically data engineering cannot exist without data science, and data science can't exist without data engineering. It used to be back in the old days, 10 years ago, I think, Vedant, when I want to say old days in this case. Yeah, it literally was a matter of it was the same person that did both. Well, as we start applying actual software engineering practices, we're recognizing there is fundamental differences between how you run the practices around data engineering and run the practices around data science. They're super related together, but it is definitely more than just one person's job. Or if you're one person, then you maybe can go ahead and justify going in and get a raise. But that's a whole other conversation. All right, next slide, please. I just finish it up there you go. And so when you look at these architectures, basically the big data architectures and data lakes, this is what it comes down. You've got these input sources, whether it's batch or streaming. You're going to put this into a data lake, and you're going to go ahead and have data consumers do the AI and reporting. Well, Delta Lake covers that concept from the input sources to the data lake, and prepping you for the data consumer such that you can store the data in structured and semi-structured, pull data from various input sources. You have a single central location, so you're not actually going ahead and having these data silos anymore. It's open and accessible, and again, designed for SQL, and more importantly, for today's session, machine learning as a single source of truth. Next slide, please. So in the end, because of this, you could presumably say, let's go ahead and build ourselves a super complex pipeline to basically to be able to handle the streaming of your data and the batch of data. I'm not going to go through all the details. I've done this before, but the point is that this picture is an accurate view of when you try to handle streaming and batch data before you ever get to AI and reporting. But if you flip to the next slide, what you'll notice is that we're going to ask the question, can it be simplified? And that's what it comes down to. Delta Lake allows us to do all of that because it handles the batching, the streaming, the updates, deletes, the consistent reads, the ability to do rollbacks, optimize file layout formats. Next slide, please. And so, yeah, let's skip that. That's fine. I think I've already beaten that one. So perfect. So this is a great segue. Now we're going to have Vedant go ahead and cover about SageMaker Studio, just in case you're not aware of that.
Yeah, thanks, Denny. So yeah, I'll quickly walk through some slides and then and introduce everyone to SageMaker Studio. So Denny talked about the whole data science lifecycle and the importance of having high quality, reliable data for building your machine learning models, right? So that's a separate pipeline. It's a data pipeline involving data engineers and data stewards. And then once you have that data in the right format, you want to derive value out of that data, right? And that's where all these different machine learning tools come into place. And SageMaker Studio is a state-of-the-art, fully integrated development environment designed specifically for that purpose. It's designed specifically for building machine learning pipelines and accommodating all these different personas, not from the data world, but now from the machine learning world. So you have data scientists, machine learning engineers, ML ops experts, et cetera, right? So all these different users need one environment and one unified visual interface. So that's exactly what SageMaker Studio provides. It provides you purpose-built tools for every step of machine learning development, including labeling data, data preparation, feature engineering, bias detection, explainability, and then all the way down to hosting these models in a very efficient way, and doing model monitoring, et cetera. You can write code, track experiments, visualize the data, debug, and monitor all of that within a single environment. And all of these different steps of your machine learning workflow are tracked within that same environment, as we will show you in the demo. So we discussed earlier the benefits of using Delta Lake for machine learning. Well, SageMaker Studio makes for an ideal user interface and offers an underlying compute platform for building machine learning applications on that data reliability layer built on top of Delta Lake. So that's because when we combine SageMaker Studio with Delta Lake, you get this optimized storage alongside data governance and data reliability capabilities. And then you also get the end-to-end machine learning capabilities and model governance through SageMaker, along with access to state-of-the-art machine learning models and solution templates. So what are these state-of-the-art machine learning models? Well, SageMaker Studio, being this machine learning platform, gives you access to all these latest and greatest built-in algorithms. So, for all the different kinds of applications that you may want to build, different modalities of data that you may have, and being able to perform machine learning training at scale, SageMaker Studio provides all these different kinds of algorithms, right? So you have supervised machine learning algorithms, you have computer vision algorithms, advanced computer vision algorithms like semantic segmentation, and then you have text-based algorithm. Large language models is a big deal today, these days, and we will talk about that in a little bit as well. And then you have purpose-built algorithms such as forecasting, et cetera, right? So we have unsupervised, supervised, and also semi-supervised algorithms. So all of those are packaged within SageMaker Studio. You can also use the API to call these models, which I will show you in a little bit. And then we have the service called SageMaker Jumpstart. So all these models are pre-packaged within containers. And there are some proprietary models as well as publicly available models. These are basically targeting generative AI use cases. So SageMaker Studio makes it very easy for end users to access all these different models within one location, fine-tune them, train them, and deploy them behind endpoints within Studio as well. And all of that is happening obviously in the AWS cloud. So you can get access to all these different features if you have the AWS cloud already. And now, in order to actually get access, you need an environment, and that's where SageMaker Studio notebooks come into play. So SageMaker Studio allows you to do data pre-processing, analytics, and building machine learning workflows all within one notebook. There are built-in integrations with Spark. We talked about the importance of Spark in building these data pipelines. So there's built-in integration with Spark and also other open source projects such as Hive and Presto that are basically running behind what we call Amazon Elastic MapReduce clusters. And then you have data residing on S3. And if you have other data sources, Studio has built-in connectors for those data sources as well. And you can browse and query these different data sources, explore metadata, the schemas, and run analytics jobs, as well as run end-to-end machine learning workflows. Depending on the kind of framework that you're using, if you're using PyTorch, TensorFlow, and others, there's built-in support for that as well, using our deep learning containers. And you don't have to leave our notebook environment in order to build these workflows. So these studio notebooks, they're fully managed. They're built on top of open source Jupyter Lab notebooks, and we have a great blog post talking about all the open source extensions that AWS has helped build for Jupyter Lab. But the point is that these notebooks are fully managed and they run on elastic compute resources, taking full advantage of the AWS or the scalability of the AWS cloud, along with the economies of scale. So you can pick all these different algorithms from within these notebooks. There are 15 built-in algorithms at this moment, probably more now. We keep adding more and more new algorithms based on the latest and greatest innovations that are happening in the open source community, as well as algorithms that are being built within Amazon. Amazon has been in the business of machine learning for the past more than 20 years, I believe now. So there's plenty of knowledge that is being transferred from Amazon also into SageMaker Studio. So you can run these models at a small scale. You can run these models at a large scale in a distributed fashion. We provide the controls to the end users. And then you have some pre-built solution templates also. So these are, CloudFormation templates, service catalog templates that allow you to, take end-to-end use cases such as, fraud detection for the banking industry, or visual inspection automation for the manufacturing industry. It brings in different AWS components, and with one click, you can deploy these machine learning solutions from data all the way to inferencing endpoints. And then we also have automated machine learning capabilities. We all know the importance of AutoML in what we do as machine learning practitioners. So we have that capability built in using Autopilot within SageMaker. And then SageMaker, using what I talked about earlier, our deep learning containers, we have optimized these different popular open source frameworks such as TensorFlow, PyTorch, MXNet, and even Hugging Face now, to be able to run these model training jobs at scale and with minimal, modification of code and so on. So today, data scientists can use SageMaker Studio to spin up these notebooks and start building these machine learning models. Machine learning engineers, as well as data scientists and ML ops experts can all collaborate and come together within this one environment to build these end-to-end workflows. So that being said, the focus is going to be on Delta Lake and Studio integration for today. So there are really these two concepts within SageMaker Studio. One is you can run these data prep jobs, analytical jobs, data exploratory jobs locally within the Studio notebook environment. But then there's also the option, like if you are really looking for that scale to prepare your data and to be able to run those data preparation jobs at scale, you can also connect to these remote EMR clusters with a click of a button, okay? And that gives you the ability to bring in the data, use Delta Lake to have, that data reliability layer, read the data from Delta Lake into EMR, and run your analytical pre-processing workloads at scale in an optimized fashion before you really get to the point of building, having this train validation test split and really start building these machine learning models and doing everything else that comes after, right? And so we also enable, fine-grained access, that is credential push-down capabilities. So if you want fine-grained security permissions where you have multiple users in a single environment, SageMaker Studio gives you that capability. And then finally, if you have to automate all these different machine learning components from the data exploratory and data pre-processing stage all the way to the inferencing and model monitoring stage, Studio gives you the ability to automate all of that as well via the API. And also we also have now a scheduling feature within SageMaker Studio that allows you to do that. So I'm going to walk through the demo. I have a couple of Studio notebooks to show you. So this is the SageMaker Studio environment. In order to access SageMaker Studio, number one, you have to be an AWS customer, which means that you have to have an account on Amazon Web Services. And you should be able to log in and have the required permissions to be able to access SageMaker Studio, which is all practically managed through our IAM roles. And so once you have an AWS account, you can just go into Amazon SageMaker. You can search from here. You can go into Amazon SageMaker. And this is the grand SageMaker console, right? Which has all these different machine learning capabilities from data labeling using what we call a ground truth service to model inferencing. We have many different kinds of endpoints. We have a batch inferencing service as well. And then there are other capabilities around machine learning. You can also build, for every model that you create, there's model governance capabilities. So you can build these model cards and have metadata around these different models and see how these different models evolved, how the data sets that were used to create these models, you can get access to those data sets and look at those as well. In order to access SageMaker Studio specifically, you have to go into the SageMaker domains section. You can have multiple domains here. We also have the ability to build collaborative workspaces. So that's when you have multiple users and you want to track changes on the notebooks, etc. So once you have a domain, it takes a few minutes to create a studio domain. This is backed by an IAM role. So in order to be able to log into a domain, you need to have access, you need to have IAM access to that particular studio domain. And you can have multiple domains based on the kind of use cases that you're working on. And also within each domain, you can have multiple users. So depending on, you can have multiple data scientists, you can, again, depending on the job profile, you can have ML ops engineers, et cetera, collaborating with one another in a single collaborative space. So once your domain is spun up, you can access SageMaker Studio from there directly. And this is the UI for SageMaker Studio. So when you spin up SageMaker Studio for the first time, you're going to land up on this home. You're going to land on this homepage, and here there are many different options. So I talked about ingesting and preparing data. There are multiple different sources where you can ingest data from. There are built-in Amazon data services like Redshift, S3, obviously, which allow you to bring your data in directly with a single point and click. And then we have other third-party integrations as well, as you can see here. And then there are, I talked about Jumpstart models. You have access to all these different models here with a point and click. And then there's a whole suite of all these different kinds of models, depending on the kind of use case that you're dealing with. And then there is the auto ML capability that I talked about earlier. By the way, all of this is also accessible through the SageMaker SDK. So yeah, if you don't want to necessarily use the UI, you want to use your own Visual Studio or any other IDE, you can access all of these features through, or most of these features through SDK as well. And then as you build these machine learning models, there is the ability to track these models, the evolution of these models through a single UI, through this experiment tracking feature. You can schedule notebook jobs. So I'll show you that when once you have your notebook nicely prepped and ready, you can even use the notebook scheduler in order to schedule these jobs on a particular schedule. And then we have SageMaker pipelines, which allows you to plug different components of the pipeline, your machine learning pipeline, from data pre-processing to model training to auto ML to model deployment. All of that can be done automated through SageMaker pipelines. And then finally, we have our own model registry, and then this is the deployment section where you can see all the different models that are deployed. There, again, like I said before, there are multiple different kinds of endpoints that you can use to deploy your models, and so on and so forth. So talking about Delta Lake, so one interesting feature is that you can actually connect to a remote cluster, as I talked about earlier. So if you want to use Spark to process your Delta Lake data that is sitting on Amazon S3, here's a cluster feature within this very familiar Jupyter Lab kind of environment. You have this cluster feature. So here, for example, I have these two clusters. running. So one is, let's say, a pre-processing cluster, which is a standard optimized Spark cluster that allows you to run these Spark workloads. And then I have a very specific machine learning cluster as well. So I can connect directly to these clusters from within the notebook itself. And then we have these concepts of these kernels, depending on what you're trying to do. We have many purpose-built and optimized container kernels and images for that purpose. So if you wanted to use MXNet, latest and greatest version of MXNet or of PyTorch, TensorFlow, etc., all of that is available to you in a fully managed fashion at your fingertips without you having to install that, manage all those dependencies yourself, etc., right? And then you have access to all these different instance types. We also enable there are certain fast launch instances as well. There's support for spot instances, for better economies of scale, etc. Right. So, as Delta Lake users, you might already be familiar with a lot of these concepts that I'll show you in the first notebook. I have two notebooks that I'll walk you through. The first notebook is where we're going to take this data that is openly available. It's the lending club data. And it's got this loan risk data, right? So it's like basically certain feature columns that show all the different loans given out in these different states to different users, along with some information about the users, such as their FICO score, and then information about the loan term, and then also information whether or not the user was approved for the loan, right? So you can get this data in Delta Lake. You can manipulate the data, run analytics at scale, get that data reliability layer, and then once you have that, you can build and manage a machine learning lifecycle, which determines whether or not a user will be approved for a loan, right? So that's the idea. So here, first, once we have this cluster, access to this cluster, you can see this is the cluster ID. You can get this cluster ID from the EMR console, the Elastic MapReduce console within AWS. And here we can see we are connected to that cluster. We have access to the Spark UI from within the notebook. And then in order to be able to read Delta Lake data into EMR, we need to run some, we need to configure the cluster to grab those dependencies, grab the open source library, the Delta Core library, and pass some external configurations. And once we do that, it's going to restart the Spark application, and then essentially you have your Delta Lake library loaded into your EMR cluster for you to be able to run all these processing steps for your data. So first, we're going to import the data, and we're going to create a raw table. So the data that we have is in Parquet format. By the way, this is data that is openly available. This notebook, this is going to be on GitHub, or it's already on GitHub. So you can just download or clone the GitHub repository and run this notebook. And yeah, so the data set is in a Parquet format. It's I think it's a few hundred gigabytes of Parquet, if I'm not mistaken. So we read this data set using Spark into the EMR cluster that we are connected to, and that's exactly what we are doing here. And once we do that, we can run some pre-processing steps on the data, right? Now we want to kind of highlight the differences between open source Parquet and the open source Delta Lake format. Delta Lake is built on top of Parquet. It does use Parquet as a default storage, and then it has an additional metadata layer for the data reliability and schema enforcement and things of that nature that Denny talked about previously in his slides. So here we are going to convert data directly from Parquet into Delta Lake while keeping it in place. So first we create a database, we define the location of the database, and this is where we're going to, once we have read this Parquet data into this Spark data frame called data, we're going to write it out in a Delta Lake format, and it's very easy to do that with, using Spark. We're going to partition by the address or the state where the loan was given out from. And then we're going to write that out back into S3, and then we ran some pre-processing steps. And if you're familiar with a bronze, silver, gold stages within Delta Lake. We're going to write the processed Delta Lake table. That's the silver table in a separate S3 location. We're going to create two separate Delta Lake tables for those data sets. So one is for the raw data, and then one is for the cleansed data, right? And this is we can see that here within Studio. You can call, you can use a SQL. Here is SQL extension to analyze your data. There's also built-in visualization within Studio notebooks. So here, if I wanted to create a bar chart or a pie chart, I can do that from within the notebook itself. I can do a describe table. Here you can see the schema of the table. And then if I look at the S3 location where the Delta Lake data is stored, this is the metadata. All of that is being stored in a JSON format, right? So that's kind of the difference between Parquet and Delta Lake, is that Delta Lake adds that external metadata storage for giving end users data reliability on top of open source Parquet. And then Delta Lake also provides full DML support on top of that storage. So if you wanted to run update operations, if you wanted to delete your certain rows in your data based on some logic, or you wanted to merge, you may have new loan data come in a periodic fashion, and you wanted to make sure that you maintain this pristine data repository, which has the cleansed data set for machine learning. Delta Lake gives you this full DML support for that purpose, right? So that's exactly what we're going to show here. First, we're going to try to run these kind of operations on Parquet. For example, if you run this delete operation on top of Parquet, you can see that it errors out. It won't work on Parquet. But if we were to run that exact same delete operation on Delta Lake, it does work, right? And so that's the concept. We can see that those rows regarding with the loans that were given out in the state of Iowa, for example, were deleted from this table, Delta Lake table, whereas the same delete operation failed on Parquet. Same concept here with update. In this case, I'm going to update the count of the number of loans given out in the state of Washington. The same thing, it'll fail on Parquet, but it'll go through on Delta Lake, and that's exactly what happened here. We updated the number of loans given out in the state of Washington to 2,700, and we can see that show up in Delta Lake.
I just did want to chime in real quick. Nothing against the state of Iowa. I used to live there. That's the only reason I chose Iowa. And I currently live in Washington State. So again, that's why. So just for any of you folks who are wondering, no, there's nothing against Iowa at all here.
Yeah, and full disclosure, this is originally, I think this is Denny's notebook that I just imported into SageMaker Studio. And basically there's, you can take other notebooks as long as they're in IPNB format. You can just import them, choose the right kernel within Studio, and just, make some slight modification like the storage, etc., and just run through with these notebooks. It's very straightforward. And similarly for merging, I think everyone is very well aware of this concept within Delta Lake. But if you wanted to do in-place merges within these Delta Lake tables, you can do that as well without having to create all these separate views that we had to do back 10 years ago or prior to the Delta Lake days. And use Spark and Hive and concept, other open source projects in order to have this, merge capability. You can do these in-place merges with a simple SQL statement on top of your Delta Lake storage. And then you also have schema evolution capabilities. I showed you the metadata layer, which was also stored on S3 in JSON format. So now you can use that to make changes. You can use Spark to make changes to your schema on your Delta Lake storage, right? So That's exactly what we are going to do here. We, once we've created that merge table, we merge the schema and append to that Delta Lake path, and then eventually we'll end up making a goal table, right, which we can then use for other purposes such as reporting and analytics, etc. There's also time travel capability. So if you wanted to, let's say you injected in, you got some bogus data, you injected that into your silver table, and you wanted to clean that, you wanted to go back and restore that to a previous version without having to necessarily run compute jobs. You can do that very easily with time travel within Delta Lake. There's a describe history capability, and then you can also see, all of that is being versioned, all the data as new versions of the tables are created. Those are versioned within the Delta Lake metadata. So, and you can roll back and forward on different versions, right? So, you can see a very robust data reliability here for running these machine learning workloads. So once you have that, you can give, using SageMaker Studio, you can bring in your data scientists, MLOps engineers, et cetera, to come and now start building machine learning models on top of that Delta Lake data sitting within your S3, right? So let's look at that now real quickly. So same concept here. I just switched notebooks. And here I'm going to take the data that we just downloaded and created a Delta Lake table out of to run machine learning and run machine learning at scale. And basically take a very simple task. I mean, I showed you we have these really, state-of-the-art machine learning models for depending on the kind of use cases, generative AI, semantic segmentation, etc. But in this case, we're going to do a simple binary classification just for demo purposes, right? So same concept here. I'm going to connect to an existing cluster. I showed how you can do that with the cluster tab previously. Here I'm going to connect to the ML cluster. And then I'm going to read the Delta Lake files, right? So now you can have two things. One, there's Glue integration and Athena integration with Delta Lake. So you can have a Glue catalog of all your Delta Lake data. And there is SageMaker Studio integration with Glue as well. So you can read that data directly from the Glue catalog, right? These are permanent tables that are registered. They're managed tables that are registered with the Glue catalog. You can read them directly into Studio using Spark APIs, right? In this case, though, I'm not connected to the Glue catalog, so I'm going to go directly to S3 and load those files directly into a Spark data frame by simply saying format Delta and load those files into a data frame. I'm going to do some data munging for, specifically for machine learning. We are trying to create this column, whether, certain feature columns, right? We're trying to do some feature engineering, such as if the individual defaulted on a loan, if there was a charge off, if there were any late payments. We have kind of this transactional data in our raw storage, and I'm going to create some feature columns that are necessary for machine learning. So that's exactly what I'm doing here. And then I create a view, right? And so, like I mentioned earlier, you can use the SQL view to view your data. And the other great thing about Studio, SageMaker Studio, and using this cluster integration is that it's very easy for you to move back and forth between, using a Studio instance versus using a cluster. So you can prototype on a SageMaker Studio instance, right, on a smaller data set to test out your code. And then once you need to really run that at scale, you can simply just change this little extension here and run that on the cluster itself. Okay, so it's and that's exactly what I'm doing here. If I just say % local, I can see, this data frame essentially gets surfaced. The Spark data frame gets surfaced into a Pandas data frame on my local Studio instance. So it's running on a single node, and that's exactly what's going on here. But if I wanted to run this as a push down SQL job and visualize the data, on a larger scale, I can do that by simply pointing to this, by changing this little line here within the Jupyter notebook. Okay, so once we have that, we're going to start with the actual machine learning process where we, create the target and the the target and the feature variables. So, we have some categorical variables, some numerical variables. That's exactly what we define here. We will need this when we actually run the model training job, because you need to specify to SageMaker, to built-in algorithms within SageMaker Studio, which variables are categorical and which variables are numerical. Now, when you're running an automated tuning job or using autopilot or AutoML, there are also capabilities for automatically understanding which variables are categorical and which variables are numerical. So that capability is also available to end users. So that's exactly what we are doing here. We are going to first convert, the categorical columns as category type for built-in algorithms. And we're going to create these two data frames. There's a training data frame, and which contains about 70% of your data set. And then there's the validation data frame, right? Which once the model is trained, or once the model is going through the training process, it needs to validate the output from the training process on a data set to make sure that it's improving its accuracy as it goes through various steps of training. Once we have these two Spark data frames, now built-in algorithms won't directly read data from Delta Lake. So there is another step involved here. So these training and validation steps, validation data sets, or the data frames that we just created, need to be written out into a separate storage. Now, built-in algorithms will not read from Delta Lake, but they will read from open source Parquet. Okay. So that's exactly what we're going to do here. We are using Parquet because our data set is fairly large. Built-in algorithms also support other formats like JSON and CSV and others. But in this case, because we have a large data set, we are using Parquet. And like I mentioned earlier, this is a match made in heaven in a way, Studio, Spark, and Delta Lake, because you can take these Spark data frames and write them out into Parquet back into S3. And built-in algorithms will read that Parquet data from S3 and spin up these distributed training jobs in SageMaker Studio. Okay, and that's exactly what we're going to do here. So we're going to define some parameters for the training jobs. We have to define the S3 bucket. And this is the S3 bucket where our training and validation data sets are stored, which we just created in this step. And then we have to define some other configurations for the built-in algorithm as well. By the way, we are using XGBoost here. You have access, like I mentioned earlier, to a plethora of different libraries and algorithms such as PyTorch, TensorFlow, XGBoost, MXNet, and then proprietary algorithms and some other open source and many other open source algorithms as well. And then once we have to give this training job a name, and you'll see why that is the case in a minute. And then we'll define some hyperparameters, right? So there are many different tuning strategies. We're using AutoML. So there's different tuning strategies that you can use to get to the best machine learning model. And for those tuning strategies, we are essentially hinting to SageMaker to take certain parameter ranges into account when tuning the machine learning job. Okay. And then we have resource limits. We can define the number of training jobs and the parallel training jobs that can run at the same time. And this is important because you want to get to a model as quickly as possible, but you also want to do it in with the in an economical fashion. So this can be as distributed as you want it to be. These clusters can be very large, depending on your data set and depending on your machine learning problem. So this is where you can basically hard code those parameters. And then here you can define the strategy, right? So there are genetic algorithms that are there. In this case, we're going to use, and then there's grid search, random search, etc. In this case, we're going to use the Bayesian search. So that's exactly what we're doing here. And then we provide these training job, we pass these specifications to a variable in Python, and then we create a hyperparameter tuning job, and we go ahead and launch this tuning job. So as this tuning job, starts to kick off, in this case, for this demo, it takes about 7 to 10 minutes to complete. You can go to your SageMaker console, and if you go into the training section, first of all, there are list of algorithms that you can view here. You can also bring your own algorithm. So if you have developed an algorithm in-house, you have a container, you can just import your existing algorithm to SageMaker Studio. And then, obviously there are algorithms that are already there that we are using, for example, in this demo. And here you can see, you'll see in progress, when your training job gets kicked off, you'll actually see that in progress here. And you can go into your SageMaker training console, and you can go to each stage of your training job, and you can look at you can look at different log information, right? You can look at the location of the training data set. You can look at the parameters, the hyperparameters, and you can look at the different metrics. And then you can also, this is directly integrated with the CloudWatch. So you can also go directly to the CloudWatch console from here and debug your training job. So all of that is happening essentially in one location in a very easy to use fashion, right? So this took about 7 to 10 minutes to complete. Obviously, you can speed that up if you throw more compute to your job. You can speed that up. But once that is done, I register. I go ahead and I have the data set. The final, I have the data set in S3, and then the final model artifacts or the model metadata is also stored on S3 once the training job is completed. So I can do one of two things. So I can either call the SageMaker SDK to register the final model, if it's to my satisfaction, to the built-in model registry, or I can take the location, and there's a UI right here, and I can create a model version. So once the training job is run, I can point to the artifact, which is a zipped file, and point the model SageMaker model registry to that S3 location, and create that model in the registry, which we can then use for tracking as we train new models on new versions of the data set. So essentially with Delta Lake, you're getting this data version capability, and with SageMaker model registry, you're getting this model versioning registry as well, right? And all of that, each version of the model also comes with the appropriate training and validation data sets. So you can also tie back to which data set you use to build these particular models. You can also create endpoints from this UI itself. Of course, you can do all of that with SageMaker SDK, but you can also create these different kinds of endpoints. There are asynchronous, synchronous, real-time endpoints, different kinds of modalities depending on your use case that SageMaker provides. Of course, they're all scalable. They scale based on traffic, etc. And so all of that can be done through the UI as well. And here, if I go into this is exactly the job that I just ran. This is my my training job. If I go into this, I can see the different versions of the model, right? And then I can reject some, I can approve some, and then we can have some actions taken once these models have been approved or rejected or pending, etc.
Perfect. So yeah, we're running pretty low on time. So why don't we just wrap it up and answer at least a couple questions before we run out? Anything else that you want to call out before we do that?
No, perfect. I'm right on time, and yeah, that's the end of the demo.
Excellent, cool. So for starters, we're not going to answer all questions because we ran a little long, and that's on us. I'll primarily be me. So with that, join us at go.delta.io/Slack. Vedant and myself are there to answer questions. Number one. Number two, I just posted to everybody the GitHub repo, which these notebooks are going to be posted to. So we're going to resolve and merge that PR later today. I think the question I want to leave it with is, Harry asked a great question. What are the differences between Apache Spark, Delta Lake, Databricks, and EMR? And this one I also want to call out SageMaker Studio. So for starters, Apache Spark is a big data processing engine. Delta Lake is a storage format. Okay, and then Databricks, EMR, and SageMaker are services. Databricks, I can talk about that, and I'll let Vedant talk about Vedant talk about EMR and SageMaker. Databricks is basically your lakehouse platform service. We both work well together and slightly compete against EMR SageMaker Studio, but this is great. We're all friends too, so that's why we're on the session together. And Vedant, I'll leave you with the last words on EMR and SageMaker.
Yeah, so EMR is a big data platform that is it's a service that is it's a first party service within AWS. So it now supports Delta Lake as well, and it offers not only Spark, but there are a plethora of different big data open source projects that it offers. So I think there is Hive, there's Presto, and multiple others that are built in, which are really for building these big data workloads. And then SageMaker Studio is really like, we talked about in the slides, it's that landing, that first party platform, first party service within AWS for building your machine learning workloads end to end, right? So there are places where, like I showed, like EMR and SageMaker can play really well together. There are places where SageMaker Databricks can play really well together as well, which we won't cover in the session. Maybe we can have a separate session for that. There are overlaps between the different services, but there are also places where we can be very complementary to each other.
Perfect. Okay, we're actually at the top of the hour, so unfortunately, we're going to have to wrap it up. So I wanted to say thank you very much for everybody for attending today's session. The recording's on LinkedIn and also on YouTube. And as well, if you have any questions, again, Vedant and myself are both on the Delta user Slack, go.delta.io/Slack. And oh, yes, that's right. And Spotify, the session will also be on Spotify very soon. So again, Vedant, thank you very much for attending today, for speaking at today's session. And to everybody else, again, thank you very much for attending.
Thanks, everyone.